AC through a LC circuit, that is an inductor and a capacitor in series. Inductor and capacitor connected across an AC voltage of V equal to Vm sin omega t. For this, an instantaneous current will be flowing, and that will be same through the inductor and capacitor because they are in same series with each other. So if I assume the current through the inductor and capacitor as the reference with the dotted line, this is the current. Then in the case of inductor, we found the voltage is leading the current by pi by 2 VL, where this VL is the peak value of voltage across the inductor. Same time, we can find that in the case of capacitor, the voltage will be lagging behind the current by pi by 2. Now here the voltage across the inductor and the capacitor are found to be opposite to each other. Therefore, for analyzing this circuit, we have to fix a condition that VL is greater than VC. I am fixing a condition like this. No problem if you take VC greater than VL. Accordingly, the diagram changes. That's all. So here I am fixing that inductor voltage is greater than the capacitor voltage. Now based on this, I drew a phasor diagram for further analysis. So when I draw the phasor diagram for this one, here it's very important to note that the VL is greater than VC. The fact is very important. Okay. So when you draw the phasor diagram for quadrants, and I want the Vm sin omega t to be in the first quadrant. Therefore, accordingly, I have to consider the current. Then only I can get that V in the first quadrant. So VL greater than VC. But VL is leading the current by pi by 2 and VC is lagging the current by pi by 2. So how it should be? Let's see. I take the current along this direction. Then compared to this current, voltage across the inductor should be leading the current by pi by 2. Leading the current means going anti-clockwise. So leading the current by pi by 2. So this is VL. Then capacitor voltage is lagging the current by pi by 2. Lagging the current means clockwise you have to take. Lagging the current by pi by 2. Then it must be like this. Okay. And we have taken the condition here that VL is greater than VC. So this is the phasor diagram. Now you can see what is Vm, VL and Vm. So the difference when I take this comes as Vm over here. So Vm is only this much, and therefore this is your omega t. So that this gives Vm sin omega t. This is what I told you while drawing the diagram for L and C circuit, or any circuit involving both L and C. You have to fix a condition like this. Okay. Now from this one we can get the value of voltage V equal to Vm sin omega t and current I equal to, so this is Vm and this is Im, the current. Therefore, current is lagging behind the voltage by pi by 2. That means I equal to Im sine omega t minus pi by 2, because in this case inductor is the effect of inductor is maximum in this case. So capacitor effect is neglected. You can see that the capacitor voltage is reduced from the inductor and you are getting the effective as along the inductor. Understood this? Okay. Then Vm is equal to VL minus Vc from this one, so that Vm is equal to Im into L omega minus 1 by C omega, so that Im will be equal to Vm divided by L omega minus 1 by C omega, or which is equal to Vm divided by Z in the case, but Z here will be equal to L omega minus 1 by C omega, that is the difference between the reactance is taken as the impedance here. So here no resistance is involving, but difference between the reactances only is coming as the effective opposition of force. So this case is very particular, the drawing of the phasor diagram and the voltage and current equations. Okay. Now again two more things, that tan phi. Tan phi. What is phi here? Phi is actually pi by 2. So pi by 2 is coming as angle phi here, and therefore tan phi is equal to tan pi by 2. So tan pi by 2 is what? Tan pi by 2, tan 90. How much it is? You say it's undefined, but we take it as infinity. Okay? Sin pi by 2 by cos pi by 2. So it becomes infinite. And like that, cos phi, if I take adjacent side by hypotenuse, what is cos pi? Phi equal to pi by 2, that cos pi by 2, that means 0. So power factor is 0 and phase factor is infinite in this case. So power factor being 0, it implies that power in this LC circuit is always 0, because that defines the power in the circuit. Yes, of course. Now if you calculate the power in this LC circuit, you can get it to be equal to 0. So these are the factors coming in this LC circuit. Okay? And being power factor being 0, you can conclude one more thing, that this circuit is not involving resistor, pure inductor and capacitor only. So only if there is resistance in the circuit, there is power developed. That's another fact we can identify from the three circuits we defined or discussed.